Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem. 1404. Number of steps to reduce a number in a binary representation into 1. It's easy, it's medium marked, but it would be easy if we see the optimal solution for it. Given the binary representation of an integer as string s, return the number of steps to reduce it to 1 under the following rules. Rule number 1 is if the current number is even, then we have to divide it by 2. If the current number is odd, then we have to add 1 to it and then we have to divide it by 2. So if it is even, then we divide that number by 2, or if it's odd, then we add 1 to it and then we can divide it by 2. Got it? And it's guaranteed that you can always reach 1 for all the given test cases. Let's say the constants. So s dot length can be less than or equals to 500. That means we cannot convert these bits into integer or longs, because like it holds only 32 bits for an integer. And s consists of characters 0 or 1. So since it is a binary form, and s of 0 can be always 1, right? S of 0 is always 1. That means all binary strings starts with 1, and so we only need to manipulate the bits after starting from index 1 to n. Got it? So we need to only calculate the operations required to convert these bits. Got it? Now let's take one example. This is 1 1 0 1. So what they said, so if this is odd, then we need to, if it is odd, then we need to add 1, right? So let's see, we'll take a ops as operations. So initially it would be 0, we haven't performed any operation. So if you see the 1, what we need to do, we need to add 1 to it. So let's add 1. So if we add 1, so we'll get a carry, right? We'll get a carry, so we'll carry it to here, and it would be 1 here and then 1 1. So now we got 1 1 0. Now we'll update the operation. We have performed one operation. Now we have 0. 0 means even. Okay, so let's see one observation. So 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1. It is 0 1 2 3 4 5. So what we observe here, so all the odd numbers ends with 1, right? If the last bit is 1, then it's a odd number, okay? And if it is 0, if the bit ends with 0, right, they are, if last bit is 0, then it's even number, right? So this is one observation we know. And now let's proceed. So here we added 1 to the odd number, so it became the even. So what we need to do when we have even, so if it is even, then we have to divide it by 2. So what we'll do, we'll divide it by 2. So what do you mean by dividing it by 2 means, so if we divide any binary form, that means we are removing the last bit from that number. So for example, if you have 1 0 1 0, that means 10. If we divide it by 2, what will become? It will become 5. So if you remove the last bit from that number, which is becomes 101, that means 5. Got it? So dividing any binary representation, that means removing the last bit from that number. Got it? So removing the last bit, that means we need to remove this bit. So we have removed a bit, so this will let's increase the operation, it will become 2. So now our binary string is 111. So is this the even number or odd number? Odd, because the ending is 1. So what we'll do, when in case of odd, so we need to add 1 to it. So we are adding it. Let's increase the ops to 3. Let's add, it becomes 0. We have the carry 1, and 1 1 is 0 again, and we have 1. Now 1 1 is 0 again, and we have 1 again, so it will become 100. So now we got the 100 as a binary string. So now is this even or it is even? So what we need to do in the even? We need to divide it by 2. So I will increase the ops, I will divide it by 2, I will remove the last number. So now I see the 100 as a binary string. Is this even? Right, it is even. So what we need to do? We need to divide it by 2. So like increase the ops and we'll divide it by 2. So we'll remove the last bit. Now the remaining string is 10. So is this even? So it is even because it is ending with 0. So what we need to do when we have the even number, we need to divide it by 2. So I'll increase the ops, I will divide it by 2. So we have only one number, which is the most significant bit, MSB, and it is always be 1, and we reach it to integer 1. So our aim is to convert that binary representation to the 1. So we have converted it into 1 in 6 operations. So our answer is 6. So we'll just return 6 from here. Okay. Now let's check how we can optimize the approach, right? So how we can do that? So here if you observe what we are doing here repeatedly, so if we see a odd number, we are doing two operations. What is that? We are adding 1 to that number and then dividing it. Okay, these are the two operations. So if it is odd, then perform two operations, right? And then if it is even, then we are performing only one operation, that is dividing the binary string. So if it is odd, then we'll perform two operations, and if it is even, then we'll only perform the one operation. So is it required to make changes to the binary string always? No, right? So why? We can just traverse, right? And we are carrying the like whenever we are adding a number, right, we are adding 1 to that number, we are making we need to make sure that we need to carry forward our 1 to the other bits. Got it? Now let's try one approach. So we have 1 1 0 1. Okay, initially ops will be 0, and we'll take one thing which is carry. So initially it will be 0 because we didn't start at the operation set. So what we do is whenever we encounter 1, that means it is odd. So what we'll do, we'll just increase the ops to 2, right? We'll increase ops to 2 because we need to add 1 and then we need to divide by 2. So it will be 2 operations. So and we need to add ones, right? So if we add 1, so we'll get a carry. So what we'll do, we'll update the carry also. So we'll update carry to 1. Okay, now we got it. So what we need, the next thing is we need to remove it. So what we'll do, we don't remove it, we just ignore it, right? We just ignore it, we'll come to this bit now. This bit is 0. So what we need to do when we encounter the 0, so we'll check, do we have any carry, right? We have carry. So it would be 0 and 1. Now the answer is 1. So is this bit is even or odd? This is also odd. So now what we'll do, we'll increase the ops by 2. So now we increase the ops and carry will be still 1. Okay, what we need to do next, we'll proceed further. We'll come here. So now bit is 1. Do we have carry? Yeah, we do have carry. So what we'll do, we'll just add 1 to it. So now it becomes 0. Sorry, it is 2. 2 means even number. So even means what? It is if it is even, what we need to do, we just need to add one operation, which is we need to divide the integer. So that becomes 2, right? 2 means it is 0 and carry will be 1 again. Okay, so now we'll we need to proceed further, right? What we need to proceed further, but before proceeding further, we need to check is this the most significant bit. So if it is most significant bit, we don't need to we don't need to perform any operation on that bit, because it is the most significant bit. We reached the end and we reached to 1, so we don't need to perform anything, but we still have carry 1, right? We still have carry 1. So what we need to do, we need to add this carry to our operations. So we have carry 1, so we'll add that to the operations. So what we'll do, we'll just return these operations. Got it? So if it is carry is 0, that means we don't need to perform any operations, we don't add anything. If it is 1, then we'll add that to the operations. Got it? So what we did here, so whenever we traverse from n minus 1 to till 1 index, and what we checking, so every time we are checking, if it's odd, we are doing 2 operations. If it is even, we are doing only 1 operations, and we are making sure we will be carry forwarding the value. Got it? Okay, what is the time complexity for this one? So we are traversing from n minus 1 to 1, so it would be big of n. And what is the space complexity? We are not using any space, so it would be big of 1. Okay, now let's try to write code. Let's take the variables required. So one is the ops to store the operations, it will be 0, and then another one is to carry forward our carry value, so it would be 0 again. Then int n is equals to s dot length. Okay, now we need to traverse from int I is equals to n minus 1 to I should be greater than 0, so we don't need to go till 0, so we need to go till 1, and then I minus minus. Okay, what is the first thing we need to do? We need to fetch the bit, the last bit, which will be bit is equals to s dot caret of I will convert this into the integer, so we'll remove character 0 from it. So and then we need to check this sum is equals to bit plus carry. So if any carry is there, so then we'll add that to the bit. I will check if this sum is double equals to 1, that means it is odd number. So if it is odd, then what we need to do, we need to increase the ops by 2, so we'll add ops 2, and then we'll update carry with 1. And in else condition, that means it is even number. So if it is even, what we need to do, so we'll just increase ops with 1. Got it? So by doing this, we'll be getting the ops, and at the end, before returning the results, we need to add the carry to the ops. If any carry is present, so we'll add that and we'll return the answer. Okay, now let's run this code. Yeah, it is accepted. Let's try to submit this. Yeah, it is accepted with 0 milliseconds runtime. Yeah, if you like my content, please do like, share and subscribe. Thank you.